casual conversations about science with the scientists themselves. It's the place to be to talk science. This is Coffee and Science with your host, Rob Parks.
Howdy y'all, and welcome back to the channel. It seems like I've been streaming all day today. So thank you to Steaming Cup of Reason for that intro. It's been a while since I've used it. This is part of my Coffee and Science show that normally I would have, well, one in the morning for me and two on Sundays, but I figured, might as well do it now, because this is a subject that I've been wanting to talk about for a good long time now and just haven't been able to mark out or carve out the time to do so. Both because I've been asked about it on Flat Earth servers or on different servers, and also I've encountered it not only in the public eye or in the media, but also with guests at my public nights. I've been asked this simple question, and that question is, let's see here. Hold on a second. That's not what I wanted. The Big Bang. Is this? Let's see if I can present. Stop screen. Present. Share screen. And so if you do a Google search, and I think I'm probably just going to mess this up, but if you do a Google search, has JWST debunked the Big Bang, you're going to get things like this. No, the Big Bang Theory is not broken. Or study confirms Webb telescope debunks the Big Bang. No. So apparently there have been discussions, as you can see, or claims that the JWST has broken the Big Bang. And so what I would like to do today is to basically talk about that. And what I want to do is the format of this is the first part of this, hopefully, which will only be about half hour or so. I will lay the groundwork for what is the early universe? How do we believe that galaxies formed in the early universe? What these observations are saying, and why these observations seem to be in conflict with our previous understanding. Now, let me first by starting off by saying this, is if these papers are correct, and I'm only going to be highlighting one, I'm only going to be discussing one of these papers, but I should also say that the second half, once I've laid the groundwork, once I've gotten everything out, I will then open up the stream to anyone who wants to have a conversation. Now, ideally, I'd like to have a conversation about this, but we can have a conversation about really anything you want. Flat Earth, science in general, astronomy, but it is intended that this conversation be at least initially about JWST, early universe stuff. So I'm probably going to have to repeat that because I don't know if more people come in. The reason why I've agreed to doing that half is because SC Montreal specifically asked me if he could come onto my stream and discuss this with me online. And I would love to have that conversation, but given the chaotic nature of my life, it is very difficult for me to actually schedule something and hold to that schedule. So particularly if I am not, if I am beholden to someone else's schedule, then I try my best to keep to it. But if I'm motivated, if it's my initial point, then yeah, it's difficult for me to stay on task. But anyway, so after I'm done blabbering on, I'm gonna open it up. I'm gonna put the link to this stream on the screen and in chat, and see where it goes. I advertised this both on the Cosmology Tartaria server and also on Earth Awakens. I'm really hoping to have some flat earthers come online so I can have a conversation with them. Although apparently a couple of them really didn't like the lecture that I was giving just prior to this. So we'll see how things go in that regard. All right, so let me stop saying so and get started. Early universe. What is it? What does it look like? Well, I'm going to preface all this by saying I'm going to try to explain all of this, like I said, within 30 minutes. It is difficult for me. That is a difficult task, particularly if I want to do it justice, if I want to go into any kind of depth. Because a lot of this is probably or a good portion of this may touch on subjects you've never heard before or ideas you've never heard before, let alone understand. So please, if you have any questions, put them in the chat or the comments, and I will try to address them. But mainly, that's really what the conversation is for at the end, is to, if you have questions, come on and ask me and let me know what's going on, and let me know so we can have a dialogue as to what's going on. So I will lay out this groundwork now. Let's assume these observations are true. Let's assume these observations, which are ultimately stating that earlier galaxies, or galaxies at the earliest epochs, or epochs around, actually, let me verify. I don't want to guess at this. Right. It gives redshifts, which again wouldn't translate very much. We're talking about redshifts between, for those of you who know this, redshifts between 7.4 to 9.1. But in terms of age, we're talking about within the first 750 million years after the Big Bang. What I'm going to refer to as T equals 0, I may refer to it as the point of creation, but it is the start point of the universe as far as the Big Bang is concerned. So Big Bang states that roughly 13.8 billion years ago, the universe came into existence somehow. As I mentioned in my lecture before, the Big Bang theory does not state what the universe looked like at the point of creation. The term Big Bang is actually a divisive term coined by Fred Hoyle, who didn't like the idea of the consequence of the universe seeming to spring out of nothing. That's actually not what the Big Bang truly states, really. Mathematically, the beginning point is what we refer to as a singularity, but physics tells us that we don't understand, we cannot describe the motion of particles in a field so dense and so hot prior to a time that is equal to, I believe, 10 to the negative 43 seconds after the Big Bang. So certainly not at the point of creation. At time equals 0, our understanding of physics literally has no description of that universe. Mathematically, it comes down to a singularity. So Fred Hoyle, who believed that the universe was infinite in duration, didn't like the idea of a universe popping into existence willy-nilly, coined it the Big Bang. Nothing is in fact exploding. There is no explosion, there is no bang, there is nothing like that. And so the universe was created in some way and has expanded ever since. These observations, as I said, which state that there are massive galaxies. Massive galaxies, when I say massive galaxies, I mean galaxies that are on the order of the solar, or of our own galaxy, but maybe a little bit less, but on order. There are massive galaxies at around 750 million years ago, or after the Big Bang. Not ago, but after the Big Bang. This is far earlier than our current model of the Big Bang predicts would happen, given that dark matter is a thing and that dark matter is cold. So the problem is, if these studies are borne out, the problem is not with the Big Bang theory. The problem is with cold dark matter. The problem is with that aspect of the Big Bang theory. If these are borne out, this evidence does not suggest anything, does not nullify or break the idea of a universe springing into existence and then expanding expanding ever outward. So, how do galaxies form? Again, very roughly. When the universe first comes into existence, it is exceedingly hot. And really, it's just energy. That's it. It is simply energy. It is unimaginably hot and unimaginably small. It's very, very dense. The universe expands, and in general, if something expands, it's going to cool off. The larger the volume, the lower the temperature of that thing. So as the universe expanded, the universe cooled off. And as it cooled off, that allowed for for lack of a better term, the condensation of matter. Some of that energy field transformed itself into matter. How it did that, I don't know. I don't even know if other people know. All I know is that is what the theory states, is that at some point, mass or matter coalesced out of that energy field. The first things that were created were leptons and quarks, or baryons, or basically the building blocks of baryons. You have leptons and baryons, or what we collectively refer to as baryonic mass, or baryonic matter, which we believe may be different than dark matter. But we don't know. It's looking that way, but we don't know. So these leptons, these baryons, these quarks, they coalesced out of this energy field. Sometime during this history, which I have to say that because I am not strictly a cosmologist, I don't know, but sometime during this time period, dark matter, whatever that happens to be, also coalesced out of that energy field. Dark matter, the simplest definition of dark matter, is material that only interacts gravitationally with other material. It does not interact electrostatically, electrodynamically. It does not. It has no charge. It has no magnetic polarity. It is not affected by the strong binding force. It is not affected by the weak radioactive decay. Only interacts gravitationally. That is very important. There's a very key thing about dark matter that has a very strong implication about how dark matter behaves over time. As the universe gets colder, as the universe expands, and I'm going to just ignore inflation at the moment, as the universe gets further larger and larger. Yeah, I wish dark matter were chocolate. That would be awesome. As the universe gets larger and larger, and the universe gets colder and colder, these quarks are flying around. And these quarks, initially, any particle has a certain amount of energy associated with it, called kinetic energy. And what that does is that energy has to be low enough for something else to cause those two things to stick together to build to make a larger object. So when you have these things flying around, they are all electrically charged. Electrostatics is going to prevent them from, is going to want to oppose the creation of at least light particles. But there's this thing called the strong force, which wants to bind these particles together, wants to glue them together. Actually, the lovely carrier particle of the strong force is, and I'm not joking, literally called a gluon. It glues these particles together. And so as the temperature goes down, these particles are moving slow enough that as they get near each other, the strong force, the strongest force in the galaxy or the universe, is able to bind them together. Now, the thing to know about the strong force is that it has a really shitty range. It only acts on things at the subatomic level. So the strong force does not act on us. And so now you've got protons, you got neutrons, and you got electrons. Well, you had electrons, but you have electrons. Gets colder. Protons and electrons start binding together. Electrons start getting bound to protons. So proton is a positively charged particle, electron is a negatively charged particle. They will attract and they will become bound to each other, orbit each other, if you will. Now you have what we call neutral baryonic matter. You have a proton, you have an electron flying around it. If that proton has a neutron attached to it via the strong force, or if a proton has a neutron attached to it, then that is deuterium. That is another isotope or a type of hydrogen and so forth. As it gets colder, what you can now have is, and this is kind of counterintuitive from an astronomy or from a stellar evolution perspective, you can actually have these two things slam into each other, and instead of just blowing apart into component fragments, into quarks and so forth, they will actually hit each other and bind together. So if you get 4 hydrogen atoms and you slam them together, eventually you're going to produce helium. And that is what's called nucleosynthesis. So you have the era of particles, you have the era of neutral atoms, then you have the era of what we call nucleosynthesis, which is the creation of helium and a little bit of lithium, and that's it. Then it gets cold enough that nothing new can form. All the universe is, at this point, from a baryonic standpoint, are hydrogen atoms, helium atoms, about 75% hydrogen, 24%-ish helium, and tiny little bit of lithium. Really, really small amount of lithium. And then on top of that, you have dark matter that is already formed, and then you have the rest of the energy of the universe, which basically you can think of as heat. At one point, yes. At one point, the temperature of, like I said, the temperature when the universe was small was really unimaginably high. And then as it cooled, it eventually got to a temperature such that hydrogen fusion you have the onset of hydrogen fusion, which is roughly around 10 to 15 million Kelvin, which at that point you could basically say 10 to 15 million Celsius. And then it got colder. It got colder and colder, and now the universe is 2.7 Kelvin, but I'm getting ahead of myself. So you've got all of this material hanging out. You got these protons, you got hydrogen, helium, lithium, and a slew of electrons just flying through space. Free electrons flying through space. Now, this is where our model comes in. Cold dark matter. And what I mean by cold dark matter is dark matter that isn't moving very quickly. Basically, it doesn't have a lot of energy to it. Gravity is always a thing. Gravity is always going to want to contract things into smaller areas. Due to the fact that the universe was not homogeneous when it started, there were minute density fluctuations within that energy field. That means that these density fluctuations, these points of higher density, are going to have higher areas of gravity. They're going to contract material or gather material to them more so than areas of lesser density. we kind of refer to these as seeds. And first, that starts off with dark matter. Dark matter will start to collapse due to density fluctuations within that dark matter. They'll start to collapse into smaller chunks of dark matter. As they do so, they're going to bring that baryonic matter with them, which is going to cause density defluctuations or density enhancements within the dark matter. Excuse me, density enhancements within the baryonic matter. And then, which is going to cause gravity to cause that baryonic matter to collapse even further. Now, the dark matter gets to a certain size and then stops. The reason for this is because when you collapse something, and very much at the beginning, I said that as you get something larger, as you make something larger, volume larger, it's going to cool off. Commensurately, if you squish something, technical term, you make that volume smaller, that thing's going to heat up. And as I've mentioned before, if you heat something up, it's going to produce an outward pressure. It's not going to want to bind together into a smaller and smaller volume. It's just moving. It's too excited. It wants to be out of the room. And so it's going to cause an outward pressure, and it's going to basically will prevent it from, potentially prevent it from collapsing. The only way to get it to collapse even further, well, it will prevent it from collapsing. The only way to get things to get further is for that body, for that object, glob, to lose energy in some form. And for baryonic matter, which can electrodynamically, electrostatically interact with each other, you can have scattering. You can basically have two ships passing in the night, two atoms passing in the night, and due to their electrostatic interaction, that's going to cause the creation of a photon, and that photon's going to go flying out somewhere. Basically, because of that scattering, because the motion of these two objects has been changed due to the electrostatic force, energy is going to bleed off that system, and it's going to escape. So the speeds of these two particles, these two atoms, is going to slow. So the overall kinetic energy of your clump is going to go down, and so you can compress it even further. Cold dark matter can't do that. It can't cool, as we say. It can't interact with itself and generate photons to bleed energy from that system. And so it gets to a point where it contracts down to a certain size, and gravity no longer wins. There is an outward pressure caused by the motion of the dark matter, as it were, that resists that collapse further down. So you get what we call a dark matter halo. And these dark matter halos are bigger than the galaxies themselves. But what happens is that that dark matter halo has, like I said, brought that baryonic matter with it. And that baryonic matter has gotten close enough together. Again, density enhancements occur. That stuff starts to collapse down. You start to form molecular clouds. You start to form stars. You start to build your galaxy. In this case, you actually build what's called globular clusters, and then the galaxy in proper. I'm not going to go into supermassive black holes. That's a different subject entirely. But essentially, at that point, the baryonic matter collapses down. Because it can cool, it can collapse down and create a happy galaxy. So all of that requires time. So gravity, as we understand it, has a time scale, has what we call a free fall time scale or dynamical time scale. The amount of time that gravity needs in order to take something from here down to here. That is not an instantaneous thing. It doesn't happen in a split second. There's a certain amount of time that it does so. So our current understanding of the Big Bang with cold dark matter, hot dark matter actually makes this worse. Hot dark matter, which is a thing, theoretically, or potentially could be a thing, theoretically, is dark matter, again, matter that only interacts gravitationally, but has a higher internal temperature, has a higher amount of energy associated with it. What that means is that the cloud actually cannot get small enough. And then and so everything basically takes even longer for things to form. So with our current understanding of the dark matter content of the universe, you're going to have a certain time scale. And it's going to take, say, 1 billion years to create galaxies that are the size of the solar, or the size of the Milky Way. So you should not find a galaxy that has the mass of the Milky Way prior to, say, 1 billion years after the point of the Big Bang. Now, that's the model. That's basically what these studies are looking at. Now, I'm going to share this, and I'm going to diverge a little bit and actually talk about, or digress a little bit and actually talk about how science is done. Window. Actually, I'll put myself down here so that gets bigger. Let's see, what can I do here? Pick myself up here. Hold on. Let me do this. I'm trying something, and I'm failing. Oh no! Oop. All right, never mind. Not that important. So this is a paper that had come out recently. So one of the big journals, could there be a strong electromagnetic force that only acting on the dark matter? No. And actually, you kind of stumbled into something. One of the things that I didn't talk about was that one of the things that we believe happens is, so you have that strong force, you have that weak force, you have that electrostatic force, or electromagnetic force, rather. As the universe gets smaller, if you go backwards in time, those three forces that are separate from one another, they act differently at different time scales, use different, they use charge or what have you. They have different carrier particles. They are distinctly different forces. As you get a smaller and smaller universe, if you go backwards in time, you run this thing back, the electrostatic force and the electromagnetic force and the weak force actually become indistinguishable from one another. And that we call that the weak electromagnetic force. And then the the universe is, once you, again, going back in time, the universe gets so small and so hot and so dense that the strong force is now indistinguishable from the weak electromagnetic force, and those get combined. So you may have heard of the gut that is called the gut, or the grand unifying theory. When those three forces are coupled and you can no longer distinguish one force from the other. The toe, or theory of everything, is when you can chuck gravity into the mix. But again, that's something else entirely. So Nature is one of our premier journals. Nature is, I've only paid attention to astronomy articles. I've only paid attention to physics articles, but I believe Nature runs any kind of high-profile science research. So if you have a biology paper that's really you can publish it in Nature. It's a pain in the ass. Actually, getting your paper published in Nature is honestly a ridiculous process in comparison to getting your paper published in some other journal, like the Astrophysical Journal. But it is highly read and highly respected. So if you want your paper to be out there, and if you want your paper to get the oohs and the ahs, then you go to Nature. Now, this is the only time. Now, I haven't been doing active research for a while, so maybe this happens with other journals. But this is the first time I've encountered this formatting. So the way that normal scientific papers run is you write a paper and you submit it to your journal of choice, and they will review it, and they will send it to a referee who then does a peer review. The referee will look through your paper, look at your science, look at your results, and he will comment on it. And basically your options are thus: the author, who is anonymous, loves your work, basically has nothing to say about it, and is like, perfect, publish it now. You must. This is amazing. Publish it now. Citation index. Or what will actually happen is that the referee will come back with kibitz. They will come back with with notes. Sometimes those notes are favorable or positive in that a lot of them will be like grammatical errors or what have you, or things that are easily rectified. In other cases, the referee will ask for you to basically redo your analysis. They like the idea. They think the environmental or the experimental design or the observational design is sound, but they don't like how you analyze the data on the back end. So they may ask you to redo that, given certain conditions. Or they could say, fuck off. Your paper is garbage. Get the hell out of here. And they will recommend to the editor of the journal that this paper is shite and it is unrecoverable and it shall not be published in any form whatsoever. That is ultimately peer review. Once you've done this, and you can go through peer review a few different iterations, because then you take the review notes, you change your paper, you do the analysis, do whatever the referee asked you to do. Assuming you're not going to actually challenge the referee, which you can. You send it back. The referee looks it over. He either says, yay, or you need to do this. That basically becomes an iterative process until you finally get to, hooray, publish this. Howdy, Clive. Howdy, Real Cygnus and Flow Rider. So that's peer review. And once it's peer reviewed, once the referee has signed off, you now have a peer-reviewed article. Now, typically, what I've seen articles that are peer-reviewed, but haven't been officially published in the journal yet, and they will be put out, and you can read them. I'm trying to think of. If bear with me for a moment, maybe I can bring something up. Let's see, work or personal, Dropbox, research. Don't have anything. Papers. We'll go with, these are all my papers. So screw it. Oh, that'll work. That may, depending on the journal, may look like this. Stop screen share. Will look like this. It looks nice. You've got an abstract, you got your introduction, your analysis, yada, yada, yada. Lots of math. Clive would love this paper. Got your acknowledgments, your references, your appendices, your tables. And then you've got, because of the formatting, you've got a whole bunch of captions. Oops, where is it? Actually, this one doesn't have, for some reason, this isn't showing the plots. But typically, you would have a plot, some kind of plot with a caption. Basically, what I'm getting at is it's easy to read. This one, however, for reasons, because again, ain't like that. This is peer-reviewed, but not formatted. So it makes it really hard to read. So you got verbiage, you got figure 1, but the actual figure is way down here somewhere, and it ain't captioned. So, yes, I've lost the plot. Exactly. I say all of this because when I go through this paper, it's going to be a little bit rocky to show you how things work. So, because this formatting sucks. Now, they may have put out a nicer looking format, but I haven't checked. I got this paper a while ago. But this is a paper called A Population of Red Candidate Massive Galaxies, approximately 600 mega years after the Big Bang. So M year, this means mega year or millions of years. So right off the bat, so you got the authors. Hey, I've heard of, surprisingly, I've heard of none of them. And you've got your affiliation. So, hey, look, first author is from Australia. So all you Aussies out there, Ivo Labde, represent. You got Yale, you got Colorado Boulder, you got Pittsburgh, you got some heavy hitters. You got Penn, Niels Bohr Institute. Here is the abstract in black. First thing I want to point out is this right here. If verified with spectroscopy, the authors flat out, first thing, admit this evidence that they are going to show you in this paper is not definitive. It's a first guess. So making any kind of claim that this has debunked anything is a little premature. So they are honest. They are upfront. This is not strong evidence. It's strongly pointing to something, but it needs to be verified. And that is how science works, is you put out, you make a claim, you publish it, and then someone else has to come by and verify it typically with an independent method that basically gets the same results. All right, I'm going to speed this up a bit. So what the paper goes into is basically the JWST has looked at various fields of the sky, and actually they've looked at parts of the sky that Hubble has looked at, and ultimately they have made some certain selections. They have made some cutoffs. So when you look at an image of a sky of any particular location, you're going to get thousands of objects, potentially. Probably JWST, you're going to get millions of objects. You need to cull or identify the objects of interest as opposed to background garbage you don't care about, like stars or whatever. You're only interested in galaxies that you want. So those galaxies are going to have some kind of observational characteristic to them. And so what this is basically saying is that they are observing between 1 to 5 microns. So they're looking only at the light from 1 to 5 microns. So not visible light, not stuff that you can see, but heat radiation from 1 to 5 microns. And so they're trying to isolate galaxies that are at the redshifts between 7.4 to 9.1. I'm not going to get into what that means, other than to say that corresponds to a time frame of 500 to 700 mega years. That's the redshift. Redshift, really quick, is cosmological redshift is as things are moving away from each other, as fabric of space is getting larger, then the wavelength is getting longer, and thus the light is getting redder. Spectroscopy needs it. Ideally, yes. So depending on the redshift is a direct function of age. the larger the redshift, the farther back in time you're looking. Basically, is it. So a redshift of 2, just to give you an idea, if an object at a redshift of 2 is an object that occurred, or you're looking at it as it was when the universe was half as old as it is now. So what? 7.5, 6.5 billion years ago, 6.8 billion, something like that. I can't do math. That's why I'm not a cosmologist. So that's what Z of 2 means. A Z of 3 means that you are now 1/3 the age of the universe. You're looking at something that is 1/3 of the age of the universe, so forth and so on. So not redshift of 9 is you're looking at something that's 1/9 of the age of the universe. Yeah. So the way they did this, that's very important. That is pretty vital to this paper, to the claims this paper is making, is to get the redshift right, because that's going to tell you when these objects formed or existed. The way they do that is they're going to use a technique called spectrophotometry. So bear with me for a moment. This is where we start kind of getting into the weeds. And this is taking far longer than a half hour. I need to speed it up. Oops. Bro. So if you look at a galaxy, if you look at the spectra of the galaxy, if you look at the intensity of light as a function of wavelength, it's going to look something like this. If the galaxy is not moving relative to us, all of this stuff is going to be in the ultraviolet range. The wavelengths of this is going to be in the ultraviolet range of the E&M spectrum. But if going to further and further redshifts, that means that the relative velocity between the two objects is getting larger and larger. And so all of this gobbledygook is going to get longer in wavelength. And such that, at this point, this part of the spectrum, which we call the Lyman break, occurs. Ignore this wavelength. That's not what we're looking at here. This is actually in the visible. For these observations, the Lyman break actually occurs in the actually occurs in the infrared. So even redder than visible light. The Lyman break is when you have longward of a certain wavelength, you have you have higher intensity. Basically, you have a good amount of light coming out of it. When you go to wavelengths shorter than that Lyman break, you don't get really, the light diminishes a lot. And so that Lyman break is a great fiducial point to really know where that redshift is. So instead of looking at individual lines, trying to identify individual lines, where that can get problematic, because depending on what the spectra looks like, it gets really hairy. Also, because you're using photometry, your precision isn't great for identifying that sort of thing. So from a photometric standpoint, if you simply measure the amount of light over here and you measure the amount of light over there, and you take the ratio of the two, if it's of a certain depth, then you know you've hit the Lyman line or the Lyman break. We know where the Lyman break happens on Earth. We know what that wavelength should be at. And so now we can redshift that line, and that tells us, or we can calculate the wavelength shift from where it is in the lab to where it is observed. And that tells you the redshift. That tells you how far away it is, basically. So what did they do? Well, they did something called spectrophotometry, which is a really fancy word for, is that the one I want? Nope, not the one I want. That'll work. So in the paper, if you read it, which I recommend, you're gonna see the acronym SED, which is spectral energy distribution. Spectral energy distribution is a way of saying black body curve. Any object is going to radiate a certain amount of energy at a certain wavelength given its temperature. But on top of that, you have interactions with the individual constituent atoms. So instead of a nice smooth curve, you're going to have a curve with a whole bunch of dips in it, possibly even spikes. But you're going to have dips in it. So this blue line is the overall, or is the SED, the spectral energy distribution. And so you have these drops, these blue drops. Those are absorption lines. Photometry is this process via which you take the light from a lot of wavelengths and you add it up and you figure out how bright the light is at that point. So there we go. Actually, that's not a great example. That is, though. Let's do that. So hopefully you can see over here. I know it's small, but these regions here, this red region, this pink region, those are what we call filters. So when a spacecraft uses, like JWST, uses a particular filter, it's capturing all of the light inside that curve. So Spitzer, in this case, has a filter that captures all of the light from this SED, and it captures that, and you basically get a single value. You get a certain intensity, which is ultimately the average of all of this put together. So it's not very precise, but it is a start. And share screen, window, there. So, actually, let me just go here. Let's see if I can find it. No. So these are images of these galaxies that they're highlighting. Oh, and let me say this. They chose a certain sample of galaxies, 13 of them. Only 6 seem to violate or seem to go counter to what we expect. So 7 of these galaxies have masses that are well within prediction. 6 of them, maybe not so much. But you can see here that, and this goes from red to blue. So this is redder light, this is bluer light. So this is the same galaxy looked at using the same telescope. In this filter, you can't see it. In this filter, it's barely there. And as you continue along, I actually don't, I'm assuming these are wavelengths, but I probably should not make that assumption. But these are different filters looking at different parts of the spectral energy distribution, looking at different wavelengths. And so you can see the brightness of the star or the galaxy changes. And at this point also, these galaxies kind of look like stars. You can kind of see that they're extended, kind of see their structure, but you ain't seeing a whole lot of detail. They're just way, way too angularly small for you to see that. Anyway, hopefully you can see that the amount of light per filter is different. And so here is, in essence, what they are doing. Is they have these black points. These black points is the brightness of the galaxy averaged over the wavelengths that particular filter saw. So we're looking at 7 data points on these plots. What that pink line is peach, I guess. what that peach line is a model SED. So what they're doing is, and in this case, and I'll get into that in a second, basically they run a model which has a certain built-in set of assumptions and has a certain number of switches you can throw. And they run this model and they generate a whole lot of different SEDs, spectral energy distributions. They generate a whole lot of distributions, and they statistically compare each of those distributions to those data points. And they choose the SED, the model SED that best fits those data points statistically, where the data point pretty much lines up within the error bars, and you can kind of maybe you're able to see there's a little black line here. Oh, down here. That black line means that's the error bar to the observation. So and it matches all of those points. So all of those points have to match, lie along that model SED curve. That's basically what they're doing. Now, I told you how you got distance. How do you get mass? This is where it gets kludgy. With the model that they're generating, each of these models assumes a certain IMF, which we refer to as an initial mass function. So we have an understanding of stellar evolution. We know if you have a range of stars of various different masses, that those stars are going to live for a certain amount of time, die, and basically become no longer visible. High mass stars are going to live maybe a few million years. The lower mass stars can live up to trillions of years. Many, many times the current age of the universe. The initial mass function is when you create all of the stars in the galaxy, how many hot stars do you create? How many cold stars do you create? This is important because we know there is a mass to light ratio. We know that there is a relationship between the amount of light that a star puts out and its intrinsic mass. So you have an initial mass function. You know what all of these stars are, the brightnesses, the intrinsic luminosities of all of these stars. You add all of those up, you're going to get a certain amount of intrinsic light. So if you have 100 stars, given that range, you're going to have a certain amount of light. If you got 1,000 stars, given that range, you're going to have an even larger amount of light. More stars, more light, simply put. We also know, like I said, that there's a relationship between the amount of light you see and the amount of mass you see, or the amount of mass that's there. And that's what they're hanging their hat on, is given that initial mass function and given the luminosity, given that initial mass function, you can run the numbers, you can add more stars, you can add different types of stars, I guess. Again, assume that's in the initial mass function. You run the numbers, you basically add more stars given that function. So if you're going to add 100 stars to the mix, that basically says that a certain number have to be high mass, certain number have to be solar mass, certain number has to be low mass. And you can add, which means as you add stars, you're adding mass. That is where they're getting the mass. So all of these stars, maybe I'm stepping ahead of myself, all of these stars have SEDs or have energy curves, distributions associated with each of them, and they are different. You put them all together, you're going to get one mother lode of a spectral energy distribution. You're going to have a certain amount of light in the blue, in the ultraviolet. You're going to have a certain amount of light in the visible. You can have a certain amount of light. You're going to have a certain amount of light in the infrared. So you have a overall spectral energy distribution for that initial set of stars, given the initial number or mass of that star, of those stars. And that is what the model is doing. The model specifies how many stars you have, of what mass you have. So ultimately, you're going to get a luminous mass of this galaxy. And as you go through the paper, they went a little bit above and beyond, which is, I think, why they actually got this thing published. They didn't just run one model; they ran 5. They ran. What did they run? They ran an EASE model, EAZE. That's the acronym of the model. They ran the prospector model. They ran the bagpipes model, Bayesian analysis of galaxies for physical inference and parameter estimation. This I guarantee you, this code was written by a Scot who really, really wanted this to spell out bagpipes. That is a backronym if I've ever seen one. And then you have different types of bagpipes. Bagpipes of CSF, CMC, loggage, whatever. And then lastly, you've got an SFPS hot model. What this is saying is they used 5 different independent models, and through all of the observational data, ran the models and got out redshifts and masses. And they all were statistically identical. Within the error bars of the models, they're all basically saying the same thing. So that, again, is what they're hanging their hat on. They have these 7 data points. They generate what the entire light spectrum of the galaxy looks like, and they compare that would look like with a given redshift, a given mass, and they compare it to those 7 data points, and voila, these 6 galaxies, all appear to be massive. They appear to be of the mass of the Milky Way galaxy or less. Now, and I'm wrapping up, trust me, and I don't want to talk to you. I want to talk to you. I don't want to talk about it. So why does this need to be verified through spectroscopy? Because spectroscopy gives you a whole lot more than 7 data points. The spectroscopy is going to give you, is going to constrain the degrees of freedom of that model fit. Now you have a lot more data that you have to get right, that you have to model appropriately. So it's within the realm of possibility that those data points are being somehow biased. There is more flux in there than would be typically seen. There's less flux in there than would be typically seen. But really, it comes down to 7 data points is not as sufficient as hundreds of data points. Oh, thanks, Clive. Yeah, I'll talk to you later. Call back later. As hundreds of data points. That is why they want verification through spectroscopy. Let's talk about the problems that could happen. The one that triggers my alarm bells is that they don't take into account, their models do not take into account what's called an AGN. An AGN is an active galactic nuclei. Ultimately, what you have is a supermassive black hole. We believe supermassive black holes are at the very center of all major galaxies. You have a supermassive black hole. You have an immense accretion disk of the size of the solar system or larger, and that is dumping a lot of mass onto that black hole. And as it does so, it generates just an impressive amount of energy. It generates more energy than in an AGN, the central massive black hole, supermassive black hole generates, and its environment generates more energy than all of the galaxy combined. So if any of these stars or any of these galaxies are AGN, that is biasing the hell out of their mass luminosity estimates. They are far too bright, so therefore the true mass is actually going to be far less. So if any of these 6 are AGN, we got no problems. The mass is now going to be much lower, and things are happy. And on one hand, AGNs would be likely, because when you're talking about the early universe, there's not a lot of space. Galaxies tend to be fairly big, comparatively speaking. And so they tend to smash together pretty often. And when things smash together, again, very technical here, when things smash together, they get distorted and they throw stuff into the center of the galaxy where that supermassive black hole is. So the probability of having an AGN in the early universe, to my understanding, is actually higher than it is now. Now it's roughly about 20%. 20% of any galaxy is going to be an AGN. Back then, that fraction is going to be much higher. We don't know how much higher. That's still an open question. But many of these galaxies, not all of them, could be AGN, which means we don't have a problem. The other things to look at, and this is why they did 5 models, to sort of try to mitigate this, which is that the models themselves, the IMFs could be wrong, the initial mass functions could be wrong, the way that masses coalesce from the early universe and form these first stars may be completely different than the IMFs we see today. So, because we're talking about the first stars to have really ever formed. First generation of stars, which are all intrinsically massive. So take my word for it, the chances of the IMF for first generation stars being the same as IMFs now is not, the chance of them being different is not non-zero. That's not something to be taken lightly. So the IMFs could be wrong. There was something else. Oh, and the way they model the SED, the way they generate that SED may in fact be wrong. May be inaccurate. Because like I said, there's a lot that goes into this. There is not just the IMF, but other characteristics, the temperature, the size, so forth and so on, densities. A lot of switches can be thrown. So many of the assumptions for where to place these switches may be inaccurate. But if you do it 5 times with 5 independent models, then you mitigate that. The chances of you getting it wrong 5 times with 5 different methods is much less likely than getting it wrong with any one particular IMF. Yes, exactly. So, okay. That's it. That's the end of it. So I will now open it up. I see Cygnus in the chat. Clive, Peter, Flowrider, Stark Otter. I don't know how many of you all are still there, but and this is an invitation. You don't have to take me up on it. I can, as everyone knows, I can babble by myself forever. But there is. Oops, that's Discord. Sorry. That's my Discord link. If you want to join my Discord, you are more than welcome. If you want to join, I see Carnivore and whatever have joined my Discord. Thank you. Invite. There it is. Next. There is the StreamYard link. So if you want to come on, see, it's open to anybody. If you want to come on and have a chat, by all means do so. I have determined that I am not fat enough, so I am going to eat some Doritos. How do I do that? I don't know how to do that. He says we're eating. How about that? There we go. I think I figured it out. At the moment I was just looking at live stream or StreamYard. I wasn't looking at what's it called? YouTube. So I don't know if SC Montreal is here. Like I said, I gave him almost no notice, so who knows? But this is the thing in terms of this episode brought to you by the Northern Virginia Astronomy Club, is that this is frontier science. This is we really don't know what we're going to find science. And this is how science is done. This is how science revolutions are made. Is that you look for these things and you try to find answers to questions. So the question here is, what do the galaxies look like in the very early portions of the universe, of the age of the universe? Hubble gave us some answers, some observational data to hang our hat on, but Hubble was looking the visible, and Hubble primarily, and Hubble was smaller. All of these galaxies are really far away, which means that Lyman break is going to be the infrared. So Hubble could not see this. Hubble could not readily identify these galaxies based on that Lyman break criteria. With in addition to that, it was smaller. It's 3 times smaller than JWST. So JWST has a much further, much slower faintness limit. So now JWST can identify these galaxies, can see them and identify them as young galaxies, and can get enough light in order to get some kind of meaningful data from them. Just better or worse? Worse. Meaning from data from them. Getting data. All right. Yeah, Nimrod, do what you need. When we getting this data, and we get data that challenges the preconceived model or the previous model, or really what we're talking about is aspects of the previous model. That is a good thing. That does not nullify the model. It simply forces us to re-look at it. In a way, well, in a sense, it is a negation. But the scientific method, when you ask a question, you test, and you get a result which is contrary to your hypotheses, which in this case, the hypothesis is that all galaxies in the early part of the early times of the universe are going to be significantly smaller than the Milky Way, or significantly less massive than those in the Milky Way. If that is your hypothesis, and then you get observational evidence that has been verified that says, no, there are galaxies at that time frame that are as large or slightly as large as the Milky Way galaxy, you then have 2 options. You can throw out the baby with the bathwater, you can get rid of the entire model, or you can reconfigure it. You can you can keep the same basic premise of the model, but tweak it. This is what we had to do with exoplanets. Before the discovery of exoplanets, we believe that terrestrial rocky planets all formed to the interior of the solar system. Gas giants all formed on the outer edges or the outer parts of the solar system. We now know we find hot Jupiters right next to the host stars. So now, in other systems, we now have to look at the Nice model, which was discovered in or developed in Nice, France, and we had to retool it. We didn't throw away the idea that a solar system or a stellar system comes about from a collapsing molecular cloud pocket. What we did was we inserted planetary migration as a thing. So same model, we just tweaked it. So if this bears out, if they look at the spectroscopy for this and it confirms their findings, what that ultimately means is that the Big Bang Theory is not thrown out. Doesn't have to be thrown out. It just has to be retooled. How it gets retooled, we may not have a good answer for that. That's probably going to take a while for us for the theorists to do their thing. I'm trying to channel my inner Goldblum. Do your stuff. Go do your stuff. Hey, Jezza. Failed binary system. No, actually, that is in reference to Flat Earther that was on Toon's channel. For some reason, she believed that Sirius was the only binary star in existence. A failed binary star may, in fact, explain the formation of brown dwarfs, but not the formation of stellar systems. So when Flat Earthers, basically, and the name that pops into my head is that, and I'm not trying to pick on him, I'm not trying to zero in on him, is Whitsitt. Folks like Whitsitt or SE Montreal or whoever, they will look at these scenarios or they will look at these instances in astronomy, and there are many of them. They will look at these instances and they will say, well, the Big Bang Theory does not predict that. That is contrary to what the Big Bang Theory would say happened at that point. Well, then the Big Bang Theory is wrong. We just need to throw it out, start over. I guess I do. No, I'm sorry, Rachie. I've been babbling for an hour and 15, but yeah. But I'm glad you're here. I am definitely glad you're here. So when you look at these situations, when you look at what I have called and will continue to call open questions in astronomy, these are things that cause us to reflect back on our theories, our models. And we start off with, can we retool it? Do we have to get rid of the entire thing? Do we have to chuck out the Big Bang? And the way we make that decision is, all right, we have all of this evidence that supports the Big Bang, and there is a substantial amount of evidence that says that the Big Bang is real, is a thing, is a good descriptor, I should say. And then we have this one case or couple cases where it doesn't quite fit. These observations don't quite fit. First thing to do is you need to verify whether or not these observations are real or are telling you what you think they're telling you. Once you're confident that what you are seeing is real and what the implications that we are in fact seeing massive galaxies in the early universe that shouldn't be there according to the model, then you ask, can we retool the model to explain that? Can we retool it so that we can keep the Big Bang Theory as a whole, but then be able to, maybe somehow there is a cooling mechanism for dark matter that we don't know about. Maybe dark matter can in fact collapse faster or collapse to a smaller point, which would speed up the process. Because instead of collapsing and then having the mass wait and then collapse, the whole thing could collapse, and the baryonic matter could start off closer together, and so that would speed up the process. That you could then form. No, I don't. I'm contractually obligated. I can't show you. I've signed an NDA. I can't show you alien pics. I've been waffling, yes. So we look at these instances and we say, can we retool things? Can we retool to take this into account? Is there a mechanism via which cold dark matter can cool? And so that could potentially solve this problem. That could potentially make the prediction such that it would explain these observations. Now, if you continue, and now if this continues, if as our studies of the young Big Bang continue, and we get more and more of these open questions, then we can reach a revolutionary point. We can reach a breaking point, to the point that we're making so many changes, so many retoolings, that the model is too clunky, too unwieldy to use. Then hopefully somebody has already started down a different line of thought and has a model for us to consider to replace the Big Bang. Something radically different. The big squish or the big tear, or whatever you want to call it. Something radically different that has radically different underpinnings. But until both of those things happen, you're not going to debunk the Big Bang, because we don't have enough open questions that fly directly in the face of the Big Bang theory. The example I like to give of scientific revolutions is, one is general relativity, but also geocentrism. The position of the planets could be predicted prior to or at the 1500s and prior by the Ptolemaic system. The Earth is at the center. All things are moving around in perfect circles with uniform velocities. All right, Nimrod. Uniform velocities, yada, yada. But the problem is, with better observations, with more, with higher precision observations, then your predictions, the Ptolemaic system predictions, started failing with more and more regularity. And what they did was they threw more epicycles at it. They were like, all right, we're not going to abandon this idea of geocentrism, because if we throw more epicycles at this thing, the predictions match up. Hey, so maybe we were wrong in how many epicycles these planets, how many loop-de-loops do these planets go through as they orbit. And then ultimately, until Nimrod, hold on a second, until ultimately somebody came up with another theory, prompted by the fact that the Ptolemaic system was just redonkulously hard to use. And I did not realize that. The Ptolemaic system was redonkulously hard to use. And so that prompted Copernicus to say, wait a minute, maybe I can simplify this by taking the basic underpinning of the geocentric model, the geometric center, and replacing that with the sun. So I think we have a Nimrod.
You do.
Hey, and I can hear you. I don't know if they can hear you.
Excellent. I hope they can.
Well, folks, let me know. Rachie has a question. Couldn't they just be younger as they were created later? I'm not certain I understand that question. When you mean they, I'm assuming you mean the galaxies. So when we say that they're young, what we're saying is in relation that they were actually created earlier. than they are now. Earlier in time. I don't know if that makes sense. All right. So Nimrod, what's up?
The ceiling?
That's a trick question. That's a trick question. My previous stream, I said that up doesn't exist, so nothing.
Well, it all depends on your frame of reference, doesn't it? Your point of view.
Exactly.
The what was it? The redshift. There's another name for that, isn't there? Which I can't remember.
We can hear them, but buzzing, not bad. And yes, the galaxies. Oh, created earlier then. Okay. So yeah, apparently we're getting a little bit of buzzing from your end, but I don't think it's that bad.
I can't really help that with the way I'm going. My microphone's kind of rubbing off my jumper.
All right. Howdy.
There is a workaround I might be able to do something with.
Howdy, Blue. If you haven't been here, I was talking about the early observations, or the observations of the early universe using JWST, and that'll work. And I'm opening it up to guests. So if you want to join this conversation, you can see on YouTube, I pinned the invitation, and then you can see it tracking along the tracker. So
yes.
Anyway, feel free to come join us.
I would definitely like Rachie to pop in. She seems to be asking some very good questions.
Sure, if she's comfortable doing that, no pressure at all. But yeah, so Nimrod, what do you have any questions?
Questions to beat the band, but they can't be answered because it's how does the universe work?
Yep.
Nobody can really answer that apart from the fact that it just does.
Well, astronomers and cosmologists are trying to answer that question.
Yeah, and I always love that fact that my brother always told me the universe is not under any obligation to make sense to us.
That is definitely true. The universe is just because you don't understand something doesn't mean that it ain't real. It doesn't exist. So the universe doesn't have to make sense to you.
No, and it's just it kind of is mind-boggling, especially this dark matter and dark energy stuff. It's utter, well, from my point of view anyway, just because I don't understand it so well. It is hard to believe, but it must be there because they can measure it or something.
No, that is a very good point in the sense that when we get into cosmology, when we get into these topics of general relativity, a lot of it isn't going to be understood by the general populace, because in order to truly understand it, you have to have a certain amount you have to have background. You have to have studied this for a while. And so it comes down to trust. You kind of just have to accept it. That what I'm telling you is true, and that I'm not lying to you or misrepresenting anything, so forth.
Yeah, and you can kind of see how some of them will say, "Oh, well, you have to have faith in your science religion," and it's like, well, it's not really a religion, and it's not that I have faith, but the fact that we've got these people out there who can go and do all the other measurements to measure the universe, and they get it so accurate, and now they're measuring this thing which is very difficult to explain, and they can measure it and get very similar results to independent people who are doing it. You kind of do have to have a little bit of faith there.
Yeah. Instead of what I think is where I think they get misled is that we're not putting faith in the subject matter. We're putting faith that the people telling us the subject matter are honest. And for some reason, it seems like from the flat Earth side that a number of them think that all of this stuff comes from NASA or the government, and government
Government bad.
Government bad, government lies.
Thing is, scientists aren't really always connected to the government when they're doing these measurements. So why would they hide and lie for the government when an awful lot of them don't really like the government themselves? Because the government likes to hold things back. I mean, the United States, I mean, I remember hearing somewhere they could have had a collider which was even bigger than the one in Switzerland.
Yeah.
But the government pulled funding for it.
Yeah. If scientists are going to be pissed off at the government, it's because we don't get enough money, not because we get too much money. That we're, we get a whole lot of money. Yeah, that was
getting field checks from NASA.
Yeah, that was W. So the super collider, I can't remember exactly what it was going to be called, but the super collider was going to be built under Texas. And the thing that boggles my mind is they dug this thing out. They had like a quarter of it built. And instead of just leaving it there so that somebody else might be, when you search, somebody else can search the pockets, search the couch, get some change together and keep building it. No, they filled that sucker with concrete. So
why?
I'm guessing because they were afraid it might collapse. I hope that's the reason. But it's the government, so who knows?
I suppose. But even more reason to finish it when you've expended enough money on it already to start building it. Why just stop it? I
can understand why you would stop it. I mean, if you don't like spending that kind of money on science, then I can see stopping it. I just don't see filling it in with concrete. But yeah.
Yeah. It doesn't make any sense. No, just in the last stream, I did mention that I almost died twice there a couple of years ago, and I'm sure you'd probably like to know what happened. Yeah, and sure. I can explain if you wish.
Sure.
Yeah, basically a combination of over-the-counter migraine tablets, bad diet, and alcohol. Mm-hmm. Acute liver cirrhosis, acute liver failure. I was retaining water. And I was even turned away from accident and emergency presenting with all these symptoms. And then went in 4 times in 1 week, I think it was. I basically said, there's something wrong with me. And then I threw up in front of a doctor on a Friday evening, and they kept me in, and that.
Oh, I guess there is something wrong with it.
Yeah, I was that close that night. And they were trying to put needles in me so they could administer fluids and other medicines, but they just couldn't get a vein on me anywhere. Mm-hmm. And so that was night 1, and then a couple of days later they went to drain the fluid from my stomach. So, put in a drain site on the side. They drained liquid out of me, and my blood pressure just disappeared, and my pulse basically disappeared.
Oh shit.
Yeah. And there's something wrong with you when nurses start to panic. Right. Yeah. Now, the only thing I remember really clearly from that one was that I wanted to go to the toilet. And they wouldn't let me, and I was really annoyed at them. It's like, why won't you let me go to the toilet? I need to go.
Here's a bedpan. Use that.
Yeah, no, they didn't even offer me that.
Oh, really?
Because I was, at the time that was happening, my feet were up in the air and my head was down. They angled the bed so that they could get the blood back up to my head. So yeah, that was. But I was blissfully unaware at the time, so I just wanted to go pee. It's like I couldn't understand why they wouldn't let me either.
Yeah,
I think I had blood pressure of like 60/40 or something like that. Mm-hmm. And the nurses were panicking, and that says an awful lot.
My father was a nurse, and so I get it.
Yeah,
and he really didn't panic much. So
no, so when they do panic, it's something for you to be worried about too. But I just wanted to go to the toilet. I didn't care.
situation's bad enough. Not on top of that, you gotta pee. So
Yeah, exactly. But no, I managed.
oh, Nimrod, you have frozen up. I'll take this opportunity to say that Rachie apparently is in bed and is not feeling overly well, so she will not be joining us. Anyone else out there would like to join? Like I said, the link is in the in what's it called? The comments, and pinned in the comments, and it's scrolling across the bottom. So hopefully Nimrod will come back. Or not. Governments rarely make sense. Yeah. Kind of along those lines, yes, I will say that my research, and that's another thing, is if you look at the bottom of this thing, all right, I am going to present slides. No, that's not what I wanted. Present. Stop screen. Present. Did Jim Bump decide on which gimmicks he'll be using in his videos? I don't know. I'm thinking flat cap maybe. If you look at any paper, typically, although nature, I'm not so sure. But typically, let's see here. The references are there. The formatting of this just pisses me off. All right, there's methods, there's sample selection, there's the fits, lensing, volume, acknowledgments. So yeah, here, every scientific paper is going to have an acknowledgement section where they say thanks to folks and include folks in the include folks that contributed to the science, but not in such a significant way that they deserve authorship. But on top of that, they're going to tell you where their funding comes from. So the funding for this work came from the Alfred P. Sloan Foundation grant. Never heard of them. And it also came from this, which I'm assuming is a grant from the Spanish Ministry of Something and Innovation. No idea. I can't speak Spanish. But the point is, in the acknowledgments, and I hope Nimrod is all right. I don't see him in the comments. But the point is, we are funded by different foundations. I'm actually surprised in this case because for Americans, we're funded primarily, astronomers are funded primarily through two sources, NASA or the NSF. All of my work, or almost all of my work, was funded through NSF grants. But I know of others who were funded through NASA grants. Science, as in Sloan Digital Sky Survey, SDDS, maybe? Well, that one's without an E. That's with an E. Maybe it's that dude. All right, I think we have a Nimrod back.
Yes, you do. Can you hear me?
I can.
Excellent.
Take it we're getting rid of the video in order to help with bandwidth.
Yeah, well, I'm going over my mobile phone's internet rather than my Wi-Fi, so
Okay.
hopefully this will be a little bit more stable.
All right, so Peyton just got here, and so she was wondering what the discovery was that people are suggesting debunks the Big Bang. So I will put this back up. So this is a peer-reviewed paper, but it's awfully formatted. But just to recap, by the title, it says a population of red candidate massive galaxies approximately 600 million years ago after the Big Bang. And so the idea here is this study has identified 6 galaxies that are more massive than the current Big Bang model would have predicted at 600 billion years. So that is the reason why people are suggesting that it debunks the Big Bang. And as I've pointed out, it doesn't debunk the Big Bang. It debunks the idea of, specifically, it challenges how cold dark matter affects the formation of galaxies or the formation of stars in the early universe. And as it points out in the art abstract, this information hasn't been verified. So it's very speculative at this point. Or not very, but it's speculative at this point.
But like, isn't there a couple of options for how the universe was created, shall we say? And just the Big Bang is the best one that fits the model that we observe all the time? And may need some adjustments?
So, prior to the Big Bang, kind of going in history, prior to the Big Bang, we had what was known as the steady state model. And the steady state model essentially said that the universe was in existence at some point and that it was essentially constant, that the universe did not evolve really over time. Then Hubble came along and said, hey, the universe is expanding. That was verified. So folks like Arp and Fred Hoyle couldn't get rid of the idea that the universe was expanding, although Arp tried. And then they added they still clung to the steady state theory with the idea that as the universe was expanding, in order to keep the mass density constant, more matter was coalescing out of the energy field. Basically, they were creating matter out of nothing. So that was basically one of the main nails for the steady state theory. That's the last really strong competitive theory to the Big Bang. Now the question becomes not so much a competition or an alternate explanation to the Big Bang as an alternate explanation. Well, as I tried to harp on, I guess, is we don't know what happened at creation at t equals 0, and we certainly don't know if there was anything prior to t equals 0, or what, if there was, what that thing is. And so a lot of the models that I've seen now basically are concerned with describing that period. The steady state model was an expanding universe model? I thought it was prior to that. Oh,
didn't Einstein try to put in that the universe was a set size and wasn't expanding into one of his formulas he was creating? I remember hearing that. I don't know if it's true or not.
So, when in the early 1900s, maybe I got the name of the model wrong, but in the 1900s, they did believe that the universe was essentially static. That the universe had always been in existence and would continue to be in existence for all time. And so when Einstein came up with relativity, he basically said, all right, well, relativity really only has one action going, and that is gravity. And if you let gravity go unchecked, if you basically create a universe and then let gravity do its thing, it's going to cause that universe to collapse, which they didn't see. This is prior to Hubble, so we didn't even know about expansion. They assumed that the universe was of a certain size and it was steady, that it would stay that way. So Einstein built in to GR the cosmological constant, which is, and he admitted as such, a fudge factor. He did not specify the physical mechanism of what the cosmological constant was. what actually caused the cosmological constant. He just put it in there to have a repulsive pressure to prevent the universe from collapsing in and upon itself solely based on its mass. He referred to that as his greatest blunder when Hubble showed that the universe was expanding. He didn't think that the cosmological constant was necessary anymore because essentially the outward momentum was what was competing against gravity. But now, as it happens, we know that the universe is, we've brought it back. We know that the universe is in fact not just expanding, but accelerating. And so the cosmological constant is reemerged as the outward pressure to combat gravity.
Good thing he realized his mistake then.
Well, I don't think he ever did.
Or if it was a mistake.
What he referred to as his greatest blunder. Who knows if it is I wouldn't consider it a blunder, but I don't know by the time he was dead, his death, whether or not the cosmological constant was brought back in. Really, Clive? All right. So apparently I need to re-look at my history of that period, because from my understanding, if you have a uniform distribution of stars, Newtonian gravity would keep it static. But apparently I'm wrong, because I trust your understanding of this way better than mine.
Yeah, whereas that just is looks like someone tipped out a Scrabble, the box of Scrabble tiles all over the table to me. I mean, I have some understanding, but not the greatest, as I've said many times. I at least try to understand it, but it's not easy.
No, it isn't. And, if you can't understand it, there's nothing wrong with that. It's just some people understand it. Some people put in the time to understand it. It's choice. But really, it comes down to trust. Do folks trust folks like me to tell them the truth about what things are? The truth to our understanding, obviously, has been illustrated. I've been getting a couple of things wrong. People thought that but didn't do the math. Okay. So I want to basically be able to admit that I'm wrong if I get something wrong, and somebody that I respect and believe is more knowledgeable than me then corrects me. But I don't know where that distrust. Yeah, maybe it's the government. Maybe they just think we're all being manipulated by the government.
Yeah, the damn government. Building distrust in its general populace by just not educating them properly from the very beginning, I think is one thing an awful lot of places struggle with. I mean, look at myself and Brian's logic, for example, right? Because he's Irish as well, so him and myself are products of the Irish educational system, and look at how different we have ended up.
Yes.
Right. Whereas he just sees conspiracies everywhere, and that's fine. There's nothing wrong with doing that, but I mean, he goes a little bit too far sometimes.
See, Brian's logic, I actually just had a encounter with him, if you were, on one of Rachel's videos, and it was an example of one of the things that I was venting about and I was frustrated with, is Brian goes a little bit further in that he has told me on a few different occasions that I'm wrong, that I will tell him what modern science states, and he will just say, no, you're wrong. That is not what science says. He won't back that up. He will just tell me I'm wrong. And I just all right, it's one thing to say that, it's one thing not to believe what I tell you, in the sense of, no, I don't think the Earth is a globe. You say that the Earth is a globe, but I don't think that's what it is. It's another thing to tell me that I don't know what science is. I don't know what the current model actually is. And so, yeah, Brian is, I really would like to have a conversation with him, but yeah, I understand about that.
He's a bit special, that guy. And I'm ashamed to say that he comes from the same island as me, to be perfectly honest. But it's a lot worse over in the States.
We elected Trump, so I don't really want to get into politics, but there are a lot of people over here that, I have much differing opinions about.
Yeah, a lot of people who want to believe that conspiracies are true.
Mm-hmm.
I mean, one of the funniest ones I ever heard was PJ CNET, and the fact that he thinks that we live inside the Matrix, essentially.
Oh,
and
yeah.
Well, but what? Why? How?
That actually is not that, as conspiracy theories go, or shall I say alternate thinking goes, that's not as fringe as you might think. Elon Musk believes that. He believes in something called the, I can't remember what the, simulated something or other. He believes that we are all within a computer construct. That everything, that reality as we know it, is actually a computer model. So, yeah, Elon Musk believes that.
So is this why he has these blue sky ideas of going to Mars and stuff like that?
No, I don't think so.
Or does he just see that there's a whole load of money to be made from it?
Probably that. I would go with there's a whole lot of money to be made. And again, this is all speculation. I don't know. Obviously, I don't know Elon personally, but I would imagine that a lot of it is ego. If he is the first person to put boots on the moon or boots on Mars, his legacy is assured. His name will be in textbooks or history books for all of eternity. And I think that's why he's doing it.
I think he's kind of already there with the fact that he's got so many of these internet satellites all over the Earth now, providing fairly stable and fairly good internet, to be honest.
Well, yeah.
It's expensive as fuck, but I mean...
Yes, it's more expensive than, in my opinion, Starlink doesn't need to exist. You can find cheaper ways. But you think about GPS. Who I don't know who invented it. I don't know who the driving force behind GPS was. So I would imagine that once Elon is dead or what have you, or satellite communication becomes more ubiquitous such that Starlink isn't the only name in the game, I think in that sense, his name will be kind of forgotten. Obviously now his antics and so forth, I think he definitely has a legacy. He will be remembered, but I don't think it's going to be for what he wants it to be. I don't think his legacy is going to be as nice as he thinks it is.
Yeah, he's kind of ruined Twitter. Because I liked the shit show that was Twitter before he took over. Because it was kind of fun. You could go in and say whatever you wanted. Now you're kind of going, well, maybe I shouldn't say that because Trump will ban me. Or not Trump, Musk will ban me. It's just like, yeah, it's not free speech anymore.
Yeah, that banner had not just my email address, but also my Twitter account or Twitter handle on it. I got rid of that because I no longer am on Twitter. Because I got to the point that, brands, banners, that one.
Yeah, because I seen a tweet from him there. I think last week it was, and he was saying, or maybe it was a week beforehand, but he was saying that he's unbanned all the people he's banned or blocked, and I'm going, really? He's one of those people now. He's one of these chilly idiots. He blocks everybody and then unblocks them after a little while, and then blocks them all again.
Yeah, I do not like Elon Musk. I don't know him personally, but pretty much everything out of his mouth I find to be horrible. And where was I going with this?
I agree, but as I have said before, the fact that he is taking the pressure off of NASA of sending people up to the International Space Station and the likes of that, doing all these cargo runs for them, that's fine. They can now concentrate on doing the other stuff that NASA should be out there doing, like returning us to the moon and maybe going further. Because
SpaceX, I like SpaceX.
Yeah.
I don't like Starlink. I have a problem with mega constellations. That's a separate topic in and upon itself. But I like the idea of, or I like that SpaceX is taking the burden off of NASA. I think we're going to get into a really icky, fuzzy area of responsibility, of regulation, because now you're adding corporate America into space exploration, and I don't think anyone has given any kind of thought as to how we're going to control that, how we're going to attempt to, mitigate any kind of abuses that they might do.
We're heading into an East India Company of the space race.
Precisely.
Sort of thing.
Yeah, sort of thing. Yeah. So going on with Elon Musk, I want to say
Pirates of the Delta Quadrant.
One of the first reasons. So when Elon Musk hit the scene, and he put out his fantasy, and this is an excellent observation. When he put out the fantasy that he was going to put something on Mars, when I heard about this, I think he said something like, "I'm going to put boots on Mars." He definitively says, "Boots on Mars 2022," which was like 3 years. When I heard it, that would be 3 years. And I'm like, come again? I don't see how you're going to do that, but sure. And now he's pushed it back. In fact, I think it may have been the first one was 2020 and then 2022. And now I don't think he actually has said what it is. But at the time I thought, yeah, all right, he's a fantasist. He's just unreliable. And then the whole using Twitter to influence financial finances or the stock market, I was like, yeah, that's kind of, that's not cool with me. But what got me was there was an interview with him that really didn't get a lot of press, but there was an interview with him. And one of the questions was, are you concerned about safety sending people to Mars? Because the Apollo program was not without human cost. So are you worried about people dying on the way to Mars? Not only did he say no, he laughed. He laughed and said no. And he said, there are plenty of people who want to go to Mars, regardless of the risk. I'm like, wow, you are a disgusting human being.
That is a shitty opinion.
Yeah, it's just kind of like, ha ha ha, I can just send more, like they're lemmings or they don't matter. I'm like, are you friggin' kidding me? So that's where I really didn't care for him. And with Elon Musk, in terms of freedom of speech, that's also bullshit.
He doesn't give a shit about that. I mean, if he really truly believed in freedom of speech, he wouldn't be flying around the world in a jet that's hard to track unless you know how to do it.
Yeah, he wouldn't be banning people who are giving away the location of his jet. But now I don't know if you've heard, but the newest thing that he's done now is he is labeling news agencies state-funded or state-run news outlets. He did that to NPR, and then he did that to the BBC.
Yeah, I seen that the other day.
He has since changed it to something a little less fascist, to saying government funded, which I think is technically true. I think some of BBC's funding does come from the state.
The BBC is funded by the television license, basically. So yeah, by the state.
Yeah. So, but the implication that he's trying is basically saying that BBC is like Pravda or like Sputnik. It's state-run propaganda.
Yeah, but not really, because they have an awful lot of satire on their channel, all on their channels all the time, and they do some really good quality work. Now, yes, there is, with their news channels, there's a bit of following the government line in things, because, well, they do want to keep getting that funding from the government. But while they're following that line, they're also running satire shows like Have I Got News for You, and Mock the Week and stuff like that, and they're taking the piss out of all these politicians and stuff.
Yeah.
I mean, Boris Johnson was even on Have I Got News for You, and they ripped the piss out of him for the entire show.
Good. Couldn't have happened to a nicer person.
Exactly, and the thing is, he went back more than once.
I guess any publicity is good publicity.
This is it, and especially Have I Got News for You, because it's been going for 40 years or something like that. It's going an awfully long time. Maybe it's not 40 years, but it's an awfully long time they've been running. And yeah.
Well, Boris Johnson just seems like a kind of person who loves to make fun, make an ass out of himself. So,
yeah, and he laughs at himself. That was one of his endearing qualities. Not that I liked him at all, but I mean, he had nothing to do with my world ever, because I don't live in England and I'm not English. So it's never been anything that would affect me, really. But yeah, he does like to take the piss out of himself, and it's funny, and he'll take the joke and he'll act as if he's bothered, but he's not really. So, I mean...
Yeah. He is definitely, for all that you can say about Boris Johnson, I do think that he's good-natured, in the sense that, this sort of stuff, criticism and all that kind of just washes off him. He can laugh at himself, which certain other world or political leaders or former political leaders, I can't say the same about.
Yeah, Clive Wells, no, you're completely right. He became a very, very public figure by being on Have I Got News for You. The fact that he kept going back, knowing that he was going to be on a show like that and be the butt of all of the jokes, he loved it. And then they've also had his sister on, and her political views are way opposed to Boris's views. And they've even had his father on, and Boris and his father are basically the same person. Although his father's older, so he can get away with saying some worse stuff because he's from that generation.
Yeah.
And it's just like, wowzers, how can one family have so many different opposing views? But that's one of the great things about the fact that there is this family, and they have got these amazingly diverse political views.
So you're saying Boris's sister is Labour?
No, I don't think she's Labour, but she's not as Tory as he is, shall we say. She's a little bit more liberal, but she is still not as liberal as she could be, if you understand what I mean.
Yeah, I hear you. She's more centrist than she is left.
Yes, I think something like that. Not that I'm an expert in that sort of thing, but just from myself, just watching those programs with them on, and you're going, how is that his sister? How the difference in their way of their way of thinking, and even like his sister was even ripping the piss out of him as well. It's just like brilliant, yeah, fantastic.
Well, with siblings, you really kind of have to, regardless of political. You got to your sibling, regardless.
And then you've got the political system that's happening here in Ireland at the moment, where the two largest parties who are supposed to be opposing each other are in power with each other.
Yeah, I really don't get the whole consolidated government thing. That
it doesn't make sense. You need to have an opposing view so as things get done to an extent, rather than just grouping together and saying ha ha to the rest of everybody else, we're going to do whatever the fuck we want now, and you have no say in it because we are a dual party majority. And you can vote the other one in, and we're going to take like Fianna Fáil and Fine Gael. You can vote one of them in, and they're the same as each other. Like now, whereas 60, 70 years ago, not even that long ago, they were very, very opposing views. Like back in the 80s and 90s, they were very, very different parties back then, as composed to what they are now. It's just, and I've moved back to Ireland to see this, and I'm going, what the hell has happened here, considering how much the Irish fought to get our own government, and now we're basically doing the stuff that we kicked the Brits out for.
Yeah, I don't like. We have the two-party system here, and it has a lot of faults. But I really don't understand the whole multi-party building coalition thing. I just don't. Not that it's bad. I'm not putting any value judgments on it. Maybe it is a better system than we got here, but I just don't get it.
It has worked in the past for Ireland. I will say that it has worked in the past where you've had one party, say, we'll just pick one, Fianna Fáil. That's one of the major parties here in this country, and they've almost got a majority, and so they've taken in independents and some of the smaller parties, so they could get a proper majority going on. Things actually got done politically because of this. Now,
so
when it comes to political parties, I can just say forget the Green Party, because they are a bit of a waste of space, the Green Party. Especially what I seen when I was in Sweden. Because Sweden is one of the best countries in the world for recycling. Yeah. So much so that their power generation stations are incinerators. They actually ran out of rubbish to burn and have started buying it in from other countries.
They can buy ours. We got plenty.
So yeah, well, I'm sure Sweden has been looking at it and asking for it. I was just like, and the Green Party, they come back, we have to do this, but we're already there. We're like 5 steps ahead of the Green Party already. So yeah, bye-bye. But there's not a single political party in Sweden that would try and get into power without having the Green Party on their side. And the Green Party will flip and flop back and forth from side to side, because their ultimate goal is not being leftist or rightist, it's being environmentalist. Yeah. So, sometimes it works, sometimes it doesn't. Most of the time it doesn't, should I say.
Here with the problem, as I see it, with having a 3 or more party system, breaking the 2-party monopoly, is the 2-party system, or the third party doesn't want to put the work in. So they want to go to the presidency. They want to go to the big, big flashy offices. They don't want to become, local. They don't want to really involve themselves in local government. And that's how you build a base. That's how you build your party. Is you start off small. You win local seats. Then you win state Senate seats or state Congress seats. Become governor, and then it's a slow process, which I'm not seeing any third party legitimately trying to do that.
No, it's one of the reasons I've never really understood independent politicians, to be perfectly honest, because they're not going to get into power. They just can't. It's impossible for, could you imagine a government that was just independent?
Not really. No, they don't have the money.
Infighting would be insane.
Well, not only infight. Well, I mean, you got the Democratic Party. We might as well be, just infighting. They can't seem to figure out which way is which. From a practical standpoint, again, I can only speak to the states. The problem with having a whole bunch of independents is that money. Yes, you get donations from super PACs and government and lobbyists and all that, but you need the party in order to attract those donors. So if you just have a random group of people, you're not going to get the people aren't going to give money to you. They want to give money to an established system. So
even though that established system is broken and
it's broken,
needs to be
corrupt,
fixed.
and yeah, exactly. It's not about legislating anymore. It's if it ever was, it's about staying in power.
Yeah, and I mean, this goes into another conspiracy about government and how they're doing things. And the fact that some people are using this conspiracy to say that all the governments of the world are going to collapse because it's just unsustainable now.
Mm.
And all great societies in the world have always come to an end at some point, and how is our societal norm going to come to an end for us and maybe go into another dark ages? If we go into another dark ages, that is.
Well, going back to Elon Musk, and one of the things that he was tweeting about was the collapse of civilization because of declining birth rates, which, like, overall,
Yeah.
there's no what I find to be interesting. Mainly, I find to be interesting because nobody seemed to pick up on it. Is that globally there is no the birth rates are declining, but that's because the birth rate it wasn't exponentially increasing. It's just leveling off, but it's still increasing.
Yeah, there was
Those areas that where the birth rate is actually dropping, where you are now getting more people dying as opposed to being born.
Yeah.
All of those places, curiously, are white, or most of them are white. So when he's talking about civilization collapse, I wonder what he means by civilization.
There was a Swedish scientist guy who did a fantastic documentary on Channel 4 many years ago. And he was talking about the population increase, and he suggested that the Earth can sustain a set amount of people, and it will do it very nicely. And I think he was saying like 14 million people just for his example, where you've got 2 parents and 2 children. And right now, society is built like a pyramid, so there's not that many old people, but there's lots and lots of young people way down low. And it's slowly getting narrower at the bottom and becoming basically a square-shaped tower going up. So he had blocks indicating billions of people, and you've got 2 blocks at the bottom, 2 and 2 and 2 for each generation. And he was saying that if Earth reaches that critical mass for human population, it will stay there because you've got the same amount of deaths going on, the same amount of births going on, and it will be 2 parents and 2 kids. So your standard nuclear family sort of thing going on.
Mm-hmm.
And Earth can sustain that perfectly well. And the reason why first world countries, i.e. the ones that are usually white, have already achieved this mostly. There are some people who skew the figures, but it is almost 2.5 children in every family in an awful lot of these developed countries now.
Mm-hmm.
And the underdeveloped countries are following this as they introduce birth control and education.
Yeah.
And it's not coupled down to skin color, it's more coupled to education rather than anything else.
For me, it was Elon's broad civilization collapse. It's like,
that's a little bit, no, that's not really going to happen now, is it? It hasn't happened before.
Yeah, well, there is some speculation that China is going to run into problems because that pyramid you were talking about is actually starting to become not just a tower, but actually inverted. That there will not be enough young people to support such an aging population. And so
they're already in that problem, if I'm not mistaken, if I remember correctly.
Because of the
I remember somebody referencing that a while ago. They are in an awful lot of trouble already. I mean, China really needs to change its system. I mean, not the communist system, obviously, but a more sustainable way of keeping its population steady.
Yeah. It has, as Clive points out, China has reversed the one-child policy.
I was
Um,
just going to say that.
yeah, they're running into another difficulty with that, and I can't remember what it is. So I just remember there's a problem associated with the one-child policy. Reversing the policy has actually added another problem, unforeseen problem, but I can't remember what it is. I don't know if anyone else knows.
Maybe, I mean, maybe it's a societal problem, whereas parents don't want to have more than one kid anyway.
There is that, yes. The China is now having the same problem as Japan is, as far as I know, is that the young people just are not prioritizing reproduction.
Yeah.
They just don't want to have kids.
I mean, cost of living is atrocious now everywhere.
Yeah, exactly. It's expensive to have kids, and so if you're already low income, you don't really want to have a whole lot of kids because that's just going to make you lower income.
Yeah,
Well,
exactly. I mean, I don't know how my dad managed to be the only person working in this house that I grew up in, with two older brothers and my mother not working at all, and going to school and having all these costs and a very high mortgage. But it was possible to do it back then. You try doing that now anywhere. It's impossible.
yeah. Well,
And more people are taking the responsible route because they have access to birth control, that they don't want to have kids and aren't having kids.
Yeah.
And I know I've talked to plenty of them when I was in Sweden. The girls I worked with at the airport, that conversation came up more than once. And they were like, nope, I'm not having kids ever. I'm like, seriously, ever? Even if you meet the right guy or whatever like that. Nope, not having kids at all. And I was like, wow, is it really that bad now that you don't want to have kids?
Clive. Advantage of having kids is you can send them out to the factory to get some extra work income. Actually, sadly enough, Arkansas is allowing that to be more possible. They're actually making in Arkansas. The government of Arkansas has actually made it is getting rid of child labor protections. Like, really? Does that need to happen? Is that something that needs to be legislated? But
After all the fighting to stop that sort of thing going on.
Exactly. For
that,
me, yeah. Go ahead.
No, I mean that's also another problem I've been noticing. People aren't willing to fight back against the stupid things that governments are introducing. Look at what's going on in France at the moment, because they wanted to raise the retirement age from 62 to 64.
Oh my God! I gotta say, if you don't understand why Americans don't really care for the French as a people or as a society,
The cheese-eating surrender monkeys.
Well, but what's going on there is pure example of whether or not because essentially they have one of the lowest retirement ages I think in the developed world. That their retirement age is certainly lower than that in the States. I'm pretty sure
they certainly have that record in Europe.
Yeah, it's definitely lower than it is here. But the idea of I don't know what else is in the bill, but all I've heard is the legislation is going to raise the minimum age for pensioners, and they're going nuts. I mean, they're rioting, they're just causing all kinds of chaos and mayhem, and cats and dogs living together. Whereas we just don't get that. It's like, why are you so angry at that happening? So not that I say that I support that sort of law or that's raising the retirement age, but to react so vehemently is just, what the fuck? What are you doing?
Yeah, there was a little bit of a hullabaloo in Sweden when I was living there about the fact that they were going to raise the retirement age depending on what year you were born. And Sweden has two retirement ages. There's the age you can go on your pension, and then you can also have the age with an extra few years, and then you'll get double what you would have gotten if you didn't work the extra years. So I could retire when I was 65 in Sweden, but I could work until I was 70 to get a really, really good pension.
Okay.
Now, I was born in 83, right? Now, my ex-girlfriend, she was 3 years younger than me. She has to work until she's 73. And that's just 3 years in the difference in age. And that's for her lower retirement age. I forget what it was for the upper retirement age. But yeah, 73 from 64 to 73.
That's a bit of a jump. That's a
Yeah.
bit of a jump.
With just 3 years in the difference. It was quite unusual. But I mean, the Swedish government, fair dues to them, when they do their taxes and they do this stuff, you do get an awful lot of very good things back in medical care and very good roads, and you actually get value for money from the taxes you're paying. 30% was the minimum. So it wasn't such a bad thing for the Swedish to accept, because they could see the value in it, in working that little bit longer. And obviously now people are living longer and are healthier for longer, and it is insane to expect such an awfully large amount of old people to go when they're just way too young and start taking a pension. There's going to be a massive deficit, because the pension was never, when pensions were set up in England anyway, they were never designed to have gone on for this long, and it needs to be changed, because no one foreseen the change in medical advancements and stuff at the time. So, people live longer, you need to work longer.
Yeah, and that's the thing from my perspective is, the social contract was written in France. Rousseau, you have to give up certain personal liberties in order for society to benefit. So the idea that you are I don't think Macron and the French government are raising the retirement age for giggles. I don't think they're trying to be mean-hearted about it. It's because that is the only way they see of balancing their budget, or that's what the economy can sustain, is that the retirement age has to go up. You have to you have to give up certain civil liberties in order for the country to benefit. But I'd hate to see we try to impose Social Security on the French. I think they would just burn the capital to the ground. Because right now we're having the discussion in the United States whether or not to cut it basically completely, to get rid of the pension, or what we would call a pension. Maybe not entirely, but certainly cut back on it. And it's like, I don't even think it's really livable as it is, let alone.
No, it's not. From my own personal experience, I see my parents going with their pension. It really is very, very limited. And especially if you have got health issues, that's a large chunk of money coming out of a pension that's just about livable for a week. When you get it every week, it's just about livable. You have to plan everything out, very down to the last penny. It's utterly bonkers. I mean, it's not the worst pension in the world, or in Europe, should I say, but it's not the best one either. But you can get by in it. But for the sake of being unemployed, for example, that is even lower. Obviously, they want an incentive for you to go out and work, because you should be working rather than collecting the dole. But if you have kids, or if you have health issues and you can't work for whatever reasons, It's just not enough. And okay, yes, we have medical cards here and this, that, and the other, but it's still there are still things that cost money because that's just how the Irish government has things set it up. I have diabetes now. Fortunately, insulin is free for me always, so
Nice.
that's one good thing. Yeah, it is very nice because insulin is a life-giving medication. Um, I just had to sign a paper to say yes, I have it. Yes, I live here. Yes, I have diabetes, and that was fine. Everything's free.
That
But
ain't the case over here.
oh, I know, I've heard. But I have a blood glucose monitor which sits on the back of my arm. It
Mm.
lasts for 2 weeks and it costs €65 for
Oh,
2 weeks. So when you
a
don't
weird
have a
model.
job,
Yeah.
when you don't have a job and you're on job seekers benefits as it's called now, but I always called it dole, that's a very large chunk of money. That's at least half of one weekly payment, if not more than half of one weekly payment of the dole towards me.
Yeah.
It's just thank God that everything else that I get for my health issues is free, like any tablets and stuff like that is free because long-term illness. But I could only imagine how bad it must be if, say, we were just like the United States and have to pay for insulin. I mean, I'm blessed.
It's kind of weird. I mean, this is a while back, but there for a while, actually, the testing was free. Like testing strips were free, whereas insulin was ridiculously expensive. It's still ridiculously expensive, and I wouldn't doubt that the testing supplies are also ridiculously expensive now. But yeah, that's interesting. I wouldn't have expected. Yeah, well, I guess they got to make money somewhere, so it might as well. It's like printing.
Yeah,
Printers are really cheap, but the ink is expensive. So give away all the insulin they want, but make you pay for the
yeah. It's
testing.
cheaper to buy a new printer every time you run out of ink.
Yeah, basically.
It seriously is.
That's not overly an exaggeration.
No, it's actually true because I looked it up because I went and foolishly bought replacement cartridges for my printer downstairs, and then I looked at the cost of buying the two cartridges, and I was like, I could have bought a new printer and have money left over.
Yeah, here I just recently bought a printer for my office. I hate it. I really should not have bought it. If in hindsight, I wouldn't have bought it. But yeah, I could have. Given the cost of color and black and white ink and some of the printers that I could have purchased, yeah, I could have saved money by purchasing an all new printer rather than getting a replacement ink. But
Yep, it's just the costs of everything is just insane now. Cost of living's shot up. I mean, the first I seen empty shelves of fruit there a couple of weeks ago. First time I've ever seen it in Ireland. Whereas we had empty shelves of fruit that have always been full for us. Always. And England has it even worse because they're out of the EU. Ireland is lucky because Ireland's in the European Union, so we have access to what the EU can bring in, but it's still difficult to get it here because we're an island, and so shelves go empty. Like blueberries and raspberries and stuff like that, and you're going, wow. How could they just run out so quickly? There's a problem with the supplier, and they still haven't returned blueberries here, and you're lucky to get them in some places.
That really wouldn't bother me because I don't like fruit, but I hear what you're saying. In the United States, basically because of prompted by the pandemic, our supply chain our supply infrastructure just shit the bed, and so we still haven't quite recovered from.
No, that's going to take years.
Yeah,
and again, for us here specifically Eurocentric, the war in Ukraine has vastly affected everything. in the rest of Europe. Prices for everything has gone up. I mean, as some people say, you have to take a mortgage. You have to remortgage your house to fill up your car. And
Yeah.
fuel prices have rocketed up, and it's utterly ridiculous. I don't know how people are able to afford it. Although, having said that, now there's an awful lot more electric vehicles driving around.
Mm-hmm.
But I mean, the electricity bills are also ridiculous. I mean, I run everything as economic as possible. I've got LED light bulbs everywhere if they're going to be on anywhere.
Mm-hmm.
Conserve on electricity as much as possible. Anything that's on power save, like the television, it never really turns off properly, so I switch it off at the wall. So it's not drawing any power at all. My meter basically stops because I'm not using it. And
Nice.
yet still I have an electricity bill for a month for €400.
Jeez.
Yeah,
Jesus.
it's
Jesus.
it's
Okay.
bonkers.
I thought mine was bad, but all right. That's yeah.
It's utterly bonkers. And I'm fortunate. I'm one of the fortunate people out there. I've got a buffer that is going to help me, but that buffer is not going to be there forever if it's going to keep going on like this. And it's only going to get worse, apparently.
Well, yeah. It always the longer that war gets drawn out, the worse it's going to be for everybody.
Yeah. Well, one of the major problems here in Ireland is they're trying to sell off the electricity producer, because it was state run for years and there was nothing wrong with it.
Mm-hmm.
And certain services you just always have to accept that it will run at a loss. But as too often happens in the British Isles, is we like to sell things off because they're not making money, because we are too short-sighted to see that it's going to run at a loss no matter who owns it, public or private.
Mm-hmm.
And if you run it to try and make profit, then there's no service there at all. And so in the last few months, I've seen one of my neighbours went and got solar panels on his house. And now pretty much every other house on the estate's doing the same thing, because they're making massive savings for electricity bills.
Yeah.
The first neighbour who got his solar panels in, I was talking to him about it, and he was like, "Oh yeah, no, we're already in profit from the electricity supply board."
Wow. All right.
In what was it, 4 months, and they're already €300 in profit.
Oh, nice.
And it's been quite grey and rainy and stuff here in Dublin an awful lot the last 4 months or so, and yet
It's been gray and rainy there a lot.
Well,
anyway.
especially Dublin. Yeah, Dublin can be, because we have mountains surrounding us. It does rain an awful lot. Yeah, and it is grey an awful lot and cold. So I mean, he's making electricity. So solar panels do actually work.
Nice.
And I had my doubts about it, because I was like, yeah, but grey and rain and stuff. But he showed me the proof, and I was like, okay, yeah, they work.
Yeah, I'm actually surprised by that, because solar at this point, solar technology has kind of hit a plateau, and it's being very. The problem they have is quantum efficiency. It's the solar cells or the solar panels are not very efficient at collecting light.
No.
And getting them to be efficient at collecting light, I think, is going to take sort of a revolution in technology. But I do want to mention, yes, actually, Peter, I think the reason why you can't find any potatoes is because it is Crafty that's hoarding them, but I think it's because the little one is eating all of them. I think she is trying to, ensure the Irishness of her offspring by just force feeding it.
Crafty's little spud has been living in the potato drawer, and he has eaten all of the potatoes.
There you go.
And yeah, Rachie, I mean, all the energy companies out there are making massive profits, and they'll never reduce the price of anything. Why would they do that when you want to have profits?
Yeah, corporations suck.
I want to have all of your money. Give me all your money.
Yeah. Yeah, I don't know. Again, I don't know how. When you're talking about Rachel, when you're talking about companies, I suspect you're talking about the energy company. Again, I'm not familiar with how it works over there. Over here, I'm not actually overly familiar with how it works over here. What I can tell you about our utilities, particularly with electricity, aside from Texas is its own nightmare.
Oh, yeah.
Of course it is.
I was going to say shit show, but okay.
Well, yeah. I don't know if it's state run. I don't think it's state owned, but it is a monopoly. I get my power from Dominion Energy, and that's the only people I can get my power from. So I believe Dominion Energy is a private corporation. I don't believe they are run by the state, but it's a monopoly. And I don't know how they get around the monopoly loophole. But they do. That's one of the problems that in the States, in regards to utilities, is particularly electricity or power, is there's a monopoly involved, there's a monopoly built into the infrastructure that we haven't been able to fix.
Well, we all know the greatest conspiracy of all time as to why these companies are allowed to get away with it. It's because they're paying off the politicians.
Well, yeah, the lobbyists are a thing. I mean, they don't even hide it.
Yeah. Yeah.
So.
And this is why you have, there's competition in the market. Yeah, there is competition in the market. Only they've divided up the entire country so that there's actually no competition anywhere for anybody. And it doesn't work. And it would be significantly worse if it was the government trying to do it as well, because they obviously don't want to spend any money on investing into an infrastructure and stuff like that. And the private companies also don't want to do that because that eats into their profits.
Mm.
And it doesn't matter if it's the energy companies or whatever company out there. It's anything that was ever firstly held as a public company by the government. When it gets sold off into private hands, it does just as badly. And things get worse when it goes into private hands. I mean, if you look at the British Railways, when it was sold off into private hands, and you had all these private companies allowed to come in and run on the rails, but yet the railways themselves, the iron and infrastructure itself, was still owned by the government, who were expecting money from these private companies, but they weren't really getting enough because the infrastructure was bad and underinvested. And so you had this massive, avalanche coming and just building and building and building, and there were several very bad crashes because of it. And just no maintenance was done. And the same sort of thing is going on now in Sweden. From when I was in Sweden, I was a member of a railway preservation society. And so I'd be hearing from train drivers and that are out there, and it's just like, that the railways are in such a bad state because the state's not maintaining them, but there's all these private companies and they're complaining and they're getting money back from the government because of bad infrastructure. It's just, it shouldn't be allowed. How are you thinking that this is a logical way of making things work? You need to invest into the infrastructure so that it will work, but you're complaining and getting money back and not paying for the investment into the infrastructure you're going to be running on, and it's just this circle of destruction that keeps going on, and you're just going, oh, for fuck's sake.
Well, we're having something kind of similar, sort of a problem here in the States in terms of the railway, in that the rail companies don't want to invest in their own infrastructure. So I believe that the government owns the rails, and we have the investment, or the government has to keep up with the upkeep of the rails. But when it comes to the train cars, obviously the private companies need to keep up with that, and our rail companies don't seem to want to do that. They want to basically pay themselves in stock buybacks rather than to actually, I don't know, fix the brakes or update.
It's the circular argument that goes on, just like any sit. Just this circular destructive argument that just goes nowhere, and things just keep getting worse and worse and worse.
Yeah, they just don't want to they don't want to be far thinking. They like the short term benefit, and fixing your brakes does not give you a short term benefit.
No, I watch a couple of guys from the United States who do some very interesting YouTube videos about railways and stuff like that, and they were talking about this going on, and it's just like the underinvestment from everybody, and especially the larger companies have taken over so much, and they won't let anybody else run on their rails, in inverted commas, and they've invested so much in what they call slow cargo, such as coal, for example, which is probably why Trump wanted coal to start being mined again and opening up places that were shut down and the likes of that. I think I remember hearing something about that.
That and coal is in red states. Basically, coal is in Kentucky and West Virginia, and these are almost exclusively red states. So basically, if he starts mining coal, then he's going to make his base very, very happy.
Yep.
Georg, what is you say the peak sensitivity of solar panels or silicon solar panels? I thought they were gallium mainly, but peak solar panels is in the infrared. Do you know what the efficiency is? What is the sensitivity of solar panels these days? You say high efficiency solar panels, because I've heard that they're basically in the 10% range, but I could be making that up. But it would be. But I am curious. I'm certainly not an expert. Yeah. Oh.
Yeah, no, Clive Wells, I agree with you on both points about the solar panels and British Rail. Yes, British Rail was terrible because there was no investment put in, and it got worse when things were privatized. It started to be even more underfunded and underinvested.
So is British Rail owned by the government? Is rail...
British Rail was owned by the government. Basically, in England, there was lots and lots of small private companies that were about, and then after some time and a war, they were amalgamated into what was called the Big Four. So England was split up into 4 different regions of railways, and then there was another war and things weren't working out so great, so the government stepped in and the Big Four became British Rail, and it was underinvested because
I didn't want to invest in it.
Why would you want to pay for stuff? That's a minus in your profit margins. Yeah. And after some time, they realized that British Rail was just was a complete failure. And so it was, I think, Tory government decided to privatize things again.
Yeah, of course.
And that worked out so well.
Running joke, like Ryanair is a running joke, or worse than Ryanair?
Well, do you know what? People say Ryanair is a running joke, but I don't really think of Ryanair as being that bad if you know how it works. Because I know how it works. I've worked in airports an awful lot of my life, so I know how to get around certain things. So Ryanair is actually a good company. You pay nothing for your ticket, and you get nothing for your ticket apart from a seat on a plane going to where you want to go. But now Ryanair is turning into a bit of a joke because they're trying to have good customer service and good customer retention, whereas they already had that and could treat people like shit anyway because they were going where people wanted to go and they cost nothing.
Yeah, they were cheap. Yeah.
Yeah, but now Ryanair costs quite a bit more than it used to. And they're trying to have good customer service, but that just doesn't work because, again, they're still the cheapest option out there. I mean, I remember so many times when I was younger in my 20s going to Sweden for twopence.
Seriously?
Yeah. A return ticket was 2 pence.
Good Lord.
Yeah. So my ex-girlfriend would be looking on Ryanair all the time, and next thing there was a seat sale, and including taxes and charges, I think it cost us a tenner completely for the two of us to go to Sweden for a weekend.
Wow. Yeah,
Yeah.
that doesn't happen here.
It doesn't happen here anymore either because Ryanair now has bought itself one of the largest and youngest fleets of 737s in the world, and they have to pay for that.
Yeah.
And they also have to pay for, if their flights are delayed now, they also have to start paying out people for that because of laws that were put in place to make Ryanair pay for stuff. So they stopped being a cheap option because of law. So it's one of those things where, yeah, okay, so sometimes the American capitalist system does work. But it's a very rare occasion, especially here in Europe, where that sort of thing actually helps and is beneficial to everybody.
Yeah. Music joke.
A whole tenner, and I wouldn't kick the shite out of him either.
Yeah, when it comes to air prices here have always been ridiculous. It's always been expensive to fly in the States, but to the point that it's one of the reasons why I drive everywhere. I mean, when I've had to go to California, I've drove there from the Eastern Seaboard, or very close to the Eastern Seaboard, Atlanta, because it was literally cheaper to drive than it was to fly. Granted, this is kind of pointing towards what Peter is saying is, I wasn't really pressed for time, so the cheaper option would be to drive. But now, I don't know if that's true. I don't know if with the gas prices the way they are, I don't know whether or not it is actually cheaper to drive than it is to fly. But I generally drive anyway because it's more convenient. I like having the control of when I leave, when I get there, that sort of thing.
Yeah, this is one place where you can come in and say, well, if the railways had have invested properly in proper high-speed city-to-city links, they would have made an absolute killing if they could match the flight times. And it's not like the United States doesn't have the room or the ingenuity to do something like that. Japan did it, and they're a very, very small country and don't have that much room to be building dedicated high-speed links, but yet they managed it and are running a profit on their high-speed links.
Yeah, I wouldn't mind the travel time for railway because like I said, I'm willing to drive, so obviously I'm willing to put time in traveling. But train tickets, Amtrak tickets, are damn near the same price as plane tickets. So I'm like, why would I spend literally days traveling for the same price where I could get there in a few hours? So
and if they had really good service and really good accommodations on board, people would choose the train first.
Mm-hmm.
because honestly, sitting in a metal tube flying through the air, especially when you're somebody like me I'm not extremely tall. I'm 6'2" or thereabouts, 186 centimeters.
Same here.
I don't really have that much room in an airplane's seat.
Yep.
And I just so happen to like trains more than your average person. But I mean, if they had good service on board, I mean, they could really hit below the belt of the airlines, because you go to an airport, you have to check in, and it takes time, and you have to walk to your gate, and this, that, and the other. You go to a train station, there's your train.
Yeah.
There's no checking in, especially in the United States, because you're one single country pretty unless you're going to Canada or Mexico. Yeah. So you don't have to worry about checking in and getting your passports checked because you're going to Europe or whatever, and you're Schengen and this, that, and the other going on. You can just get on a train. And so there's no check-in time. You just get on a train and go. If they had invested in proper high-speed links, they would have won out, but they just didn't, because they were too blind to see how investment actually works out for their benefits. And they lost their when they should have done it, they didn't, and it was too late after that.
Our president, Biden, as he is now, he loves trains. He really. I'm surprised he hasn't pushed more for train infrastructure than he has, because he is famous. He doesn't fly. He has never flown.
I heard that.
Well, now he does, because of, obviously Air Force One or what have you.
He has his own private jet.
Yeah, he has to. But he before that, even as a senator, he would, if he could, he did it by rail. He never drove. He never flew. He always took the train. He's known for it. But and yeah, the Hyperloop. I really don't want to sit in a Tesla going 30 miles an hour where I don't actually have control over the Tesla. So
that Hyperloop of being stuck in a airless tunnel, that's been shown to be utter bullcrap.
Yeah, that's basically what Georg says.
It will never work. Yeah. And yes, it has. Yes, we have known about this idea for a long time, and it was proven not to work the first time around.
Yeah, but Elon is going to make it work this time somehow.
Yeah, right. He has a kilometer of track somewhere in a desert.
It's essentially a Tesla that drives at 30 miles an hour. It's under Vegas at this point. And not only that, not only has it been shown that Hyperloops are not going to work, civil engineers have also shown, at least in Vegas, the Hyperloop isn't going to do anything because the argument is, if you have the Hyperloop, then you're going to have less traffic congestion. Like civil engineers have shown him, no, actually, that's not true. Even if this thing does work, you're still going to have the same traffic congestion. You're not going to get rid of it. So yeah.
You just have to look back at early photographs of London way back when it was horses and carts, and how bad traffic was back then, and people were on horses, which is much easier to guide around through small spots and gaps than a car is, and yet they still had this clog of traffic all the time in London. There really is no way to fix it properly unless you get people off of their single vehicle into a shared vehicle, like a train or a tram or a bus.
All right.
But then, of course, with a bus, you don't get the freedom of actually it be dropping you off where you actually want to go.
Yeah, exactly. I like my control. But actually, at this point, we've been going for nearly 3 hours. I think.
Wowzers!
But thank you, Nimrod, for being on. I definitely enjoyed having this conversation. Thank you all for.
Thank you very much.
Listening to our conversation, contributing. That's great. And I am a little disappointed that there were no flat earthers who showed up, or at least no flat earthers in the chat. I was really hoping to get some back and forth with them, but maybe, my channel is minuscule, so maybe eventually they might pay attention to me.
If you build it, they will come.
Yeah, it's been a good time. Like I said, loved hanging out with you, Nimrod, and for the rest of you in the audience. So yeah, all right. I'm just gonna sign off. So it's good seeing you, Nimrod. I'll talk to you later. For the rest of you, have a good night. Well, for all of you, have a good night and peace out.
Thank you. Good night, everybody.